Hello, good morning and good afternoon. My name is Mohammed Ashraf, and I'm a senior architect working with MCS Technologies. Today, I'm going to talk about artificial intelligence and blockchain, the emerging duets. And before I go further, let me introduce the company, MCS Technologies. Basically, we are a product engineering service partner, and we have different locations across the globe: Vietnam, Malaysia, Sydney, Australia, and in the United States, Bay Area and Georgia, in India, in Chennai, right, and Bangalore, Pune. And then there are multiple excellence awards, right? As you can see here, for their quality excellence and certifications, right? Mainly in the areas of storage, cloud, and DevOps, and data center technologies, ISV services, transformation services, digital services, enterprise solutions, etc. Right? Okay, so let me come back to the topic. So, the purpose of the talk today, basically to talk about the emerging technologies, artificial intelligence and blockchain, right, as the name indicates. And then I will try to go through, most of the aspects, right, the core aspects of AI and blockchain, and then, related to the decentralized storage, and then some of the use cases of combining AI and blockchain, right? So the agenda of my talk, blockchain features, the blockchain types, blockchain application, consortium blockchain, blockchain market, Ethereum, Web 3.0, blockchain and smart contracts, decentralized storage, IPFS, Filecoin, SIA, storage, artificial intelligence, AIML, DL, and FL, which is federated learning, AI market, challenges, and blockchain combination, applications and use cases, and summary and discussion, right? So, okay, so now, these are the core areas which I'm planning to touch, today: blockchain, decentralized storage, and artificial intelligence, right? Okay, so, what do you mean by blockchain, right? It's as the name indicates, a chain of blocks, right? So in the blockchain, I'm covering, the basics: Ethereum, smart contracts, and Web 3.0, right? So blockchain is a decentralized, distributed, and public digital ledger, right? So it will record transactions across many computers. Okay, so the record cannot be altered retroactively without the alteration of all the subsequent blocks and then consensus of the network, right? And the blockchain could be the most significant development in the storage and sharing of knowledge since the advent of internet itself. Okay, so in order to change anything, right, it need the consensus of the network, right? Okay, so okay, let me take the next slide. Some of the applications before even going to what is blockchain, right? So there's something like Internet of Value, and that is what we are trying to create out of this, right? So the backbone layer of the transactions, right, and whatever the interactions, which are all to create some sort of value, right? It's called Internet of Value. And blockchain is used in legal, supply chain, government, in energy, in food, in retail, in healthcare, right? And in legal, we have smart contracts stored and on the blockchain contract partners terms, transfer of ownership, and delivery of goods or services, without legal intervention. And blockchain in supply chain, we have distributed ledger. So within the companies within the supply chain can gain the transparency to the shipment tracking, deliveries, and progress among other suppliers where no inherent trust exists. And blockchain in government, right? Blockchain offers promise as a technology to store personal identity information, criminal backgrounds, e-citizenship, authored by biometrics. And then blockchain in energy. Decentralized energy transfer and distribution are possible via microtransactions of data sent to blockchain, validated and redispersed to the grid while securing parameters of system. And then in food, blockchain, is used to store food supply chain data, the first traceability and predict origin, batching, processing, expiration, storage, temperature, right, chip, all the details. And the retail, the peer-to-peer marketplace, right? They can track the transactions and then the product information, shipment, and the bills of loading input on the blockchain and paying via Bitcoin, right? And blockchain in healthcare, all these electronic medical records are stored in blockchain, access updated via biometrics, right? Allow the demarcation of patient data to alleviate the burden of transfer records among providers, right? So these are the, 4 items basically. And then, okay, let me talk a story. Okay, let me take the Yap Island, right? This is in Micronesia, in the Pacific Ocean. And, a custom there, right? They were using a form of currency, they call stone money, right? So these are, the period of 8500 where, stone money was called fee stone or rye stone, right? It's a strange form of money. The difficulty with this money is if anybody does any transaction, the money is weighing almost probably 4 tons, 2 tons, 3 tons, 4 tons, like that. And then, some 8 feet diameter kind of thing. So they need to move, the limestone disc, right, from one place to other, by using wooden poles inside. So, several villages, they wanted to, they need to gather to move the money around. Okay, so it is, the stone money, right? And so, it was like very difficult to move the money around. So the villages found a, way to solve this problem. They actually, instead of moving the money around, they kept the money there. And then any transaction happens, they send that information to all the people in the village, right? So it's a kind of, mental distributed ledger. That is what they were. So every transaction will be recorded in their mind, right? So any dispute happens, there will be a majority, there will be election, right? People will, mainly there are people who are basically the validators, right? The eldest people over there. So they will do the validation. So it is a kind of similar concept what we are trying to use in blockchain, right? So it is like a Mendel decentralized ledger. So all the transactions are being distributed to all the parties, right? And so, that ledger is called a distributed ledger, right? So, okay, now, the real history, right? So where, like a person or a group of people, they nicknamed as Satoshi Nakamoto in 2008 to serve the public distributed ledger for Bitcoin cryptocurrency transaction, right? So this is where the blockchain is first created, right? And so blockchain 1.0, 2.0, 3.0, 4.0, right? And so now it started from currency, smart contracts, dApps, and to the industry, right? So in industry, we have, all this automation, enterprise resource planning, integration of different execution systems. So all these are, the key features of industry. So, and so there, we need to have highest degree of trust and then privacy, right? So blockchain has got that already, right? And so blockchain is useful in financial transaction, supply chain management, condition-based payments, IoT data collection, health management, and asset management, right? So, basically the decentralization and immutability and transparency and the greater trust, greater security, and, the efficiency. All these are the specialities of blockchain. So that is the reason blockchain could be the most significant development uh, in the storage and sharing, right, of knowledge since the advent of internet itself. So blockchain is nothing but aggregation of cryptography, proof of work, decentralized networks, right? So all these are basically blockchain. So now, okay, now let me just explain a core concept here. So Bitcoin is a digital currency, right? It's digital currency, and blockchain is the technology, right? So, okay, in the first case, suppose a person want to transfer $10 to person two, right? We have bank today, or we have a trusted third party, and that does, the transactions, right? And there may be a fee associated with it. In the case of, in the second picture on the right, we have A, B, C, and D, right? And so A has, originally $100, and then it is transferring, $50 to B, and B is transferring $30 to D, and D to, $10 to C. All right. So, what happens, right, when A is trying to, send a $150 to C. All right. So, if the transactions are distributed across all the nodes, everybody is aware, right? A doesn't have that much money. So it is not valid. So uh, basically, that is what the miners are doing. Some miners are special nodes. Those nodes will have all the copy of in the transactions or the distributed ledger, open public ledger, and they will validate whether the transactions are valid or not. And once whoever basically they compete each other. The miners compete each other to see who validates the transaction first, right? All the new transaction, and then once it is validated, it will be added to the blockchain, right? And so everybody has to update their copies. So that's the way the blockchain works, right? So here, okay, now these are the blocks and these are the components, right? We have node is like a full node or a partial node, where we have the full copy of the ledger or not, right? And the ledger is public, distributed, or decentralized ledger. And wallet can be hot wallet or cold wallet, and nonce number used once or number once. It is a cryptographic nonce and then hash, right? And these are the major components of a block, right? And the important thing is, if you see the right side picture, the transactions, right? Altogether, the block will have a hash, and that hash is, being punched into the next block. So the next block or the previous block will have, the previous block hash will be punched into the next blocks, right? So, that continues. So any data change, anything happens, that will change the preceding nodes basically. Okay. Okay, so now there is another core concept called public key cryptography. So here we have a set of public keys visible to anyone, and then a set of private key, which is visible only to the owner. So the private key generates a digital signature, and they send out, while for each blockchain transaction that that is being sent out, right? And then signature ensures authenticity, basically by confirming the transaction is coming from the user, and then preventing the transaction from being altered by anyone, right, once it has been issued. So any change of the transaction message in any way will cause verification to fail. So this is the public key cryptography. So it will help us to authenticate users in a peer-to-peer system, right? And so to ensure no double spending, we need to validate, who has that, who has what, right? Okay, so there is another concept called a Merkle tree, basically, which are uh, again, again using hashing. We have L1, L2, L3. These are the data blocks, and then the hash of L1, right, which is stored in the previous or just the parent node, and the hash of L2, hash of L3, and then hash of 0, 0, and 0, 1 together. They use the hash in the just parent node. So like that, it is propagating to the root node, basically, right? So the leaf is every leaf is labeled with a cryptographic hash, and then it propagates to the parent, basically, to the root, right? So what are being in the block, right? We have probably all the transactions, right, in the Bitcoin transaction, which are happening in probably a 10-minute interval, are punched in the block as well. And then similarly, we have timestamp nodes, right? And then the previous hash. So block 10, 11, 12, whatever, right? So the previous hash is being of the 10 is being punched in 11, and 11 is being punched into 12, right? So that's the way it is. So the timestamp is what recording the block, what time the block is created, right? So for each transaction, there will be the sender, the recipient, the amount of Bitcoin transferred, all this information will be there. Okay, so now we have a concept called consensus. I already talked about this before, and then mining and minting, right? So the consensus is that system which is allowing us to preserve a digitally shared truth, right? And the consensus protocol, they make sure that any new block, right, which is added, is the only one version of the truth, and that should be agreed by all the nodes in the blockchain, right? So there are different mechanisms in order to do the consensus, right? Proof of work, which is very compute intensive, and then the practical Byzantine fault tolerance, and proof of burn, proof of coverage, proof of elapsed time, proof of activity, proof of weight, proof of importance. These are proof of stake, right? And so we have mining and minting. So if it is proof of work, they call it as mining, and then proof of stake, consensus, right, algorithm, they call it as minting. So creating new crypto coin using proof of stake is basically called minting. And then public key cryptography to authenticate the users, right, in a peer-to-peer system. Okay, so now there's another thing called NFT, where non-fungible token, right? So these are a kind of cryptographic asset on a blockchain with unique identification codes and metadata, right, distinguished from each other. And the thing is, it cannot be traded. NFT cannot be traded or exchanged at equivalency, right? So this is like all this cryptocurrency, Bitcoin, whatever we call fungible tokens, right? But NFTs, right? These are not fungible tokens. So uh, so what happens is these unique cryptographic tokens cannot in existing blockchain but cannot be replicated, right? So it can represent basically the real world assets, right? Real world items like artwork, for example, right? And real estate. So we can tokenize them. Okay, so if you tokenize these tangible assets, right, buying, selling, and trading them become more efficient, right? And so there will not be any fraud, basically. That is advantage. NFTs can also function to represent individual identities, property rights, etc. Right? So uh, the NFT minting process, basically you open a crypto wallet and connect to the NFT marketplace, upload the file to the marketplace, and provide a name for the NFT, and specify the royalty payout rate and other parameters, and then NFT you can mint, right? Okay. And so the features of blockchain, we have the data stored in, whatever the data stored is immutable, open ledger, decentralization, transparency, increased capacity with security, minting, quick settlement, consensus, privacy and security. So these are different features of blockchain. And the types of blockchain, we have public blockchain, private blockchain, permissionless blockchain, and permissioned blockchain, right? So here in public blockchain, as the name indicates, they are public, and so anyone can join them, right, and validate the transaction. The private blockchain, they are restricted and limited to some business networks, right? And then a single entity or a consortium control the membership. Okay, so the market, we are talking about 163.8, 83 billion by 2029. These are the, blockchain technology market, the global market, right? This is done by Grandview Research. Okay, so now we are talking about the consortium blockchain, right? These are partially decentralized, and then privacy of data and faster transaction speed and more controllable, right? So so this is like a semi-decentralized network, right? So the members are not granted to a single entity. Instead, it is granted to a group of individual or nodes. Okay, so it offers network security that public chains don't. Okay, so type of blockchain technologies, we have public, we have private, hybrid, and consortium. Okay, and then advantages, disadvantages, and the use cases are given. So in the case of consortium, we have access control, scalability, and security. And the use cases are banking, research, and supply chain, right? And the disadvantage is transparency, right? It's not transparent to all the nodes. Similarly, for private, we have access control and performance, but trust and auditability is less. And then it is used in supply chain and asset ownership, right? And similarly, in the case of public, we have independence, transparency, and trust, right? And then we have it is used in cryptocurrency and document validation. Performance and scalability, security, all these are the disadvantages of public blockchains. Okay, now what is dApps, right? These are decentralized applications run on peer-to-peer network, and then they are based on blockchain. And basically they are resistant to attacks and have high fault tolerance. So usually tokenized ownership and identity management. So the left side, what we see is the normal, application. And the right side is what we see is the dApps. Okay, so now the Bitcoin network interactions. We have on the left, we have full node. We have light nodes. So full node is the one which is having the full copy of the ledger, basically all the transactions, right? And light nodes are not having all the transactions. And then here the miners produce new blocks and feed them into the nodes, and the nodes are the one to validate the transactions, right? So nodes share their blocks and their transaction with each other, right? So there is no single blockchain. Everybody will have some sort of they store their own copies, right? And all nodes do their best to stay in sync. And finally, the nodes feed the miners all the pending transactions from the mempool. Okay. And so, what is Ethereum, right? So this is a decentralized open source blockchain, right, with the smart contract functionality. Either is the native cryptocurrency of the platform, right? So among cryptocurrencies, Ether is actually the second, largest to Bitcoin in terms of market capitalization. Ethereum was conceived in 2013 by a programmer called Vitalik Buterin, right? So the advantage of Ethereum, right, which is making or building the decentralized application much easier than ever, right? So instead of launching a new blockchain for every dApp, right, you can build thousands of application on top of Ethereum platform. right? So, wherever there are decentralized applications, right, Ethereum is a framework to do that, right? Okay. Okay, so now talk about the smart contracts. So we have, a predefined contract, right? And the terms and conditions are all agreed by the, all the parties involved. And then, events basically, all these executions are triggered by some events. And, executions are automatic and they do the quick settlement, right? And highly efficient way. So these are self-executing, letter strict, immutable, and difficult to secure, right? They have a fees and gas, right, associated with it for the hour of labor to run a contract, right? So there's a predefined, for each action, right? This whatever the gas. So you bid on the price of gas, right? So you have contracts, which are run by Ethereum, and then Bitcoin, right, which is the value, which is a decentralized payment system. And then in the right side, we have to know the full nodes, the gets, missed, and parity. Full node is a program that fully validates the transactions and blocks. All full nodes are smart contracts wallets, right? And the light nodes are partial blockchain copy, low memory requirements, third-party reliance, and easy to operate, right? So, the Ethereum fees basically, which are the, gas used, right? Hours of labor into wage per hour. So how many hours are being run and what is the per hour cost? That's the way to calculate the Ethereum fees. Okay, so now what do you mean by tokenization of asset? So here, basically the tokenization of asset means it's a process by which an issuer creates digital tokens on a distributed ledger, right, or a blockchain. So, what did it represent? This is basically a digital or a, physical asset, and we'll have a token for it, right? And so, benefits of tokenization, you know, what are they? Basically, the increased liquidity, faster settlement, lower cost, bolstered, risk management from exotic assets like, artwork, sports teams and racehorses, to traditional assets like bonds and real estate, venture capital funds and commodities. Almost every asset class can be tokenized, right? So we have, different day property, diamond, copper, or whatever, right? So we have a ownership certificate, and we pass that to a, web platform, and then punch into blockchain, create the token, and then there's asset to back and it can be fungible or non-fungible tokens, right? So that's a flow. And so finally we have Web 3.0, right? So these are the decentralized, private and secure way of doing the web basically. So here Web 3.0 is user centric, right? In Web 2.0 it was information centric, right? And so that is the new age technology, right? So there are a lot of advantages, and and then the complexity also getting increased, right? When you go to 2.0 to 3.0, right? So we have what is next? Okay, so now the scalability, execution, storage, and consensus, right? So here. We are talking about the blockchain. We have cryptography, we have decentralized consensus, and then the cryptographic truth, right? So we have, the golden nodes, and then, deterministic computing, all the details. And so what happens is there is something called blockchain trilemma, right? Where we have scalability and decentralization and security, in a triangle. So, basically the number of computation network, right, which can, how many computations it can run, right? per second. That is the scalability, basically. And the centralized number of full nodes participating in the network. And then the security is the number of resources required to corrupt the network consensus, right? So, basically this is a trilemma, right? So, okay. So now we'll take to one of the application, right? So we go to decentralized storage, and then we'll talk about IPFS, Filecoin, SNIA, and storage. So what are these decentralized storage, right? So here data is encrypted and stored across multiple locations or nodes, right? And then individual or an organization, they can share the extra, disk space for a fee, right? But only the owner of the data, right, who holds the private encryption key can get the access, right? Storage providers cannot access the data. They use the blockchain to track, storage transactions, right? So that is, the decentralized storage. And so if you see on the left side, these are shared storage, right? We have a single storage, which can be easier to fail, basically. And then the second one is, the decentralized storage, where the files are split and then kept in many nodes, right? And then different storage providers are there. Okay, so if you see the right, we have different file coins, or the cryptocurrency for each of the products like ARV, BitTorrent, Filecoin, Safe Network, SIA, storage. And out of this, ARV and then Safe Network are not blockchain based. Others are blockchain based, right? And then there is a coin associated with each of these. So we have BitTorrent token and Filecoin. Safe coin is not blockchain, and SIA coin and storage. So we have different tokens associated with it. Okay, so now in the decentralized storage, we have, it is actually cheaper than the cloud storage, and it is, safe to store sensitive information, faster upload and download speeds, more security from cyber attackers, 24/7 availability with zero downtime, and then more control over the data and personal information. So now what are the factors to consider, right, when you go for a decentralized storage? So the persistent mechanism, incentive structure, data retention enforcement, decentrality, and consensus. So Ethereum itself can be used as a decentralized storage system, right? And when it comes to code storage and smart contracts, Ethereum was not designed for large storage, right? The chain is steadily growing to terabyte kind of range size. And when it grows much, it lacks the feasibility, right? And the cost of deploying, this information, right? This much data to mainnet would be very expensive due to the gas fee. Okay, so that we may need to even find for a different chain or a methodology to store large amount of data in a decentralized way. Right, so we have, the right, we have, the file, right, we are uploading, we are encrypting, we are splitting, and then distributing, right, and then identify the nodes, reconstitute the segments, decrypt, and assemble the file, right? So these are different steps. Okay, so now, okay, another example, decentralized storage. These are, for the storage. So we have first step, basically this, storing of big, like files in a big data center. Basically, it's vulnerable to outages and attacks, right? And then if you are storing thousands of distributed nodes all across the globe, and then users can use just like AWS S3 and things like that. It is not that much risky, basically, right? It's not centralized. So, different steps, right? In the case of Tadigate or storage. So we have different, so retrieve optimal nodes, encrypt and ensure, the code object, upload pieces of nodes, store metadata on satellite, ongoing audit and repair, retrieve piece location, stream data in parallel, decode and decrypt, right? So these are different steps involved here. And then, Filecoin, right? So this is again blockchain-based digital storage system. And then actually it is built on top of IPFS, interplanetary file system, right? And relies on miners to provide storage on decentralized network, right? By utilizing a peer-to-peer storage system instead of cloud storage platform, data is protected from central point of failure, rising storage cost and monitoring, right? Uh, and then users pay cryptocurrency FIL, right? FIL to store their files, right? And then miners or whatever the storage nodes earn also fills, for the storage, right? So Filecoin is a peer-to-peer network that stores files built, and then they are actually getting economic incentives to ensure files are stored reliably over time, right? And so this also address some of the limitation of HTTP for distributed storage. So on the right to the picture, right, we have a user device and user pays miner to store the file, and then miner commits publicly via the Filecoin's blockchain to store the file, and the network constantly verify the miners are storing files correctly, and then uh, user pays miner to retrieve their files back again. So user device will use to retrieve the file back, right? So for that also they have to pay. Okay. Now IPFS, right, which is like a peer-to-peer decentralized system, and then the file system for the blockchain environment, right? So now the protocol is, basically it doesn't use blockchain technology directly, but IPFS can host, manage, and share data, suitable for storing on blockchain. So here we have storage and retrieval, right? When we add the content to IPFS network, the data is split into chunks of 256K, and each chunk will have its own hash. The chunks are then distributed to various nodes of network. In the IPFS network file, right, once it is identified with hash, once user requests a file, the request traverses to nodes where the hash is existing using DHT, right? If the data points to other chunks, even they are searched in the same way, right? Once all the chunks are obtained, all of them will be simply concatenated to obtain the main object, right? So, when you put the file in an IPFS, right, and there's a smart contract and other things, IPFS returns a file hash, and then owner can query the smart contract for the public key of the worker, and then basically there will be a shared thing, right? Here we have encryption, and then store all the encrypted shares on the blockchain, right? So once you split the file to multiple shares, right? So multiple divided chunks, they randomly basically choose the keys of the encryption, and then they store the data in blockchain, right? That these are the steps in our IPFS, right? And then in the case of storage, again, it's a decentralized storage system where users run the redundant drive space and earn tokens, right? Here, every file is encrypted and then split into pieces and stored in a global network of nodes, right? And so here satellites are involved, for communication. So here, there are no possibility of data breaches and downtime because these are all, decentralized, right? And then storing data on infrastructure, basically, we'll have like thousands of nodes, and then they are all operating in a zero trust environment. All right, and there is something called delegated authority, to create access grants, and it can protect against a ransomware type of attacks, right? So, before uploading the file into the network, basically store the encrypts the file using AES 250 GCM encryption key, and then breaks them down to 80 pieces, and then they put them spread across diverse geographies and ISPs, and so no unauthorized user gets in access to the data, right? And then for retrieving, they require around make it 29 pieces and get it. So the right side, you'll see the file is being sharded, and then it is going via a storage a bridge into the farmer, right? The farmers are the one who lease out the disk space, right? So now the last one, the SIA, right? Again, it is an open marketplace for decentralized storage space, and then providers put up collateral, and then storage providers are penalized for non-performance, right? Hosts are rated by speed, reliability, and equipment cost. Storage providers are paid only when their storage is used. Each storage provider is bound by cryptographic file contract, right? And so, here we have, it works on proof of storage basically, and the mechanism where verifies issues, challenges to renders to prove that they are indeed storing the data. Okay, now SIA miners can monetize their extra uh, unused storage space and then earn rewards in the form of SIA coin, right? So this is an active token for SIA platform. So in contrast to Storj, SIA coin is not fixed and can be minted indefinitely, right? SIA funds are the other component of SIA's unique to coin system that incentivizes the investors of SIA network, right? And then it is currently one of the top decentralized data storage platform, right? So SIA blockchain offers like easy to use cloud storage in addition to current driving liability. SIA allows anyone with a spare hard drive to earn a passive income with the crypto using SIA platform, right? So the SIA project is meant to create distributed decentralized network for cloud data storage, right? Okay, so now we'll touch the last part of the game, artificial intelligence, right? AI, ML, DL, and FL. Basically, both are deep learning. So here, what do you mean by artificial intelligence, right? Uh, basically intelligence, right? That is something human possess, right? So ability of the machines to imitate human intelligence is called artificial intelligence, right? So, in the case of machine learning, there are algorithms which incorporate intelligence to machines, right, by automatically learning from data. And then deep learning, which is like a deep neural network algorithm that mimics human brain to incorporate intelligence into machine, right? So, and then federated learning is also a deep learning, decentralized deep learning technology, which allows users to update the models cooperatively, without sharing their data, right? So here, different components, right? We know AI is, the power of machine to copy intelligent human behavior. And so the components are machine learning, cognitive computing, computer vision, natural language processing, neural network, and deep learning, right? So in the case of artificial intelligence, the program can reason, sense, act, as well as adapt. Okay, in the case of machine learning, algorithms can do uh, actually some data. It can learn from some data over a period of time, right? And then deep learning is nothing but the multi-layered neural network, right, which are used for getting the intelligence, learning, and other things. So different examples, right? We have human vision versus computer vision, right? So what a computer see and what we see, right? And the smart vehicle, right? We have 360-degree view of the driverless car, for example, which can sense everything behind, right? Everything around, different cameras, sensors, object detections, and then AI can do the decision, right? And then vision application. Similarly, industrial robots, mobile robots, right? So, and then in sports, there are different sensors, different inputs, different scores, and then the prediction, right? Many things can be used, using the artificial intelligence techniques, right? Okay. Now the AI market we are talking about, global market is around 1,597 billion by 2030, right? And then the different main characteristics and the top common challenges in AI, like a feature engineering, AI and artificial neural network, deep learning, natural language processing, intelligent robotics perception, automate similar repetitive task, data ingestion. These are the main characteristics. And then the challenges, the computing power, right? The amount of power needed for the algorithm to run, right? And then trust deficit, limited knowledge, human level, and then data privacy and security, the bias problem, data security. Okay, now most of our machine learning happens in a centralized way, right? So we are actually having a training algorithm, whatever, and so the training data is being put into one centralized place, and then training data, sample data, right, and then to identify patterns and transcend it. So the machine then uses the algorithm to learn such patterns and identify the uh, in bigger chunks of data similar to sample data. So we are basically feeding the rules and data to classical programming and to get answers. But in the case of machine learning, we are feeding data and answers to get the rules, right? Okay. So machine learning and deep learning here, we have input, right, and then whether it to identify as a car or a not car, whatever, right? So feature extraction, and then there's a classification algorithm which shows whether it's car or not car classified. In the case of deep learning, we have the feature extraction and classification together coming in the deep learning algorithm basically. So input is fed to the deep learning thing, feature extraction and classification happens, and then whether it's a car or not car, right? That output is the classification is coming out. It's a sample, right? Okay, so now the federated learning. So now what happens is the centralized machine learning. We have issues, right? So how do we design algorithms framework to work well for federated learning? So the data we are keeping at the edge, the mobile device or local device. We are not sending the data to a central place, right? And then the training happens differently here, right? So we have a global model and local update, and so the collaborative learning is in such a way that they train the algorithm in a decentralized edge devices, right, without exchanging any of the data basically. So we'll have multiple actors to build a common and robust machine learning model without sharding the data. Similarly, the data privacy, security, access right, access to heterogeneous data, all these are the normal issues happening in regular framework, which will not happen here because we are not sharing the data, right? And so applications are spread over a number of industries, including defense, telecommunication, IoT, and pharmaceuticals, right? So federated learning, we can do the next word prediction in mobile phone, for example, right? And then we can have devices communicate with a central server periodically to learn a global model. Federated learning helps to preserve user privacy and reduce certain strain on the network by keeping data localized. Okay, so okay, can the data leave at the edge, right? So we have if you have that at the edge, we have improved latency. It can work offline. We have better battery life, privacy advantage, right? All these are possible. Okay, so in the case of federated learning, we have multiple entities they're collaboratively solving a machine learning problem, right? So there will be a coordination is being done by a central server or a service provider, but each client's raw data is stored locally, right? And they are not exchanging the data or transferring the data, right? Instead, focused on the updates intended for the immediate aggregation, right? And so in the ML world, the approach to model training is centralized, right? But in the case of federated learning, it's a kind of decentralized, right? So here this is federated averaging where temperature sensor readings are taken, and then there's a federated mean and a federated average. Okay, so now again continuing this. This is an example of hospital data because nobody wanted to put the hospital data or patient data to the cloud or centralized place. So let the data in locally be there, and then we do some sort of analytics on top of it, right? So we have personal data, fog, and edge data. All these are huge. Sending them to cloud is hard also. So federated learning can help you, right? And so personal healthcare, if you want to do over a heterogeneous network, right, for multiple hospitals, this can be done, right? And similarly, for the individual hospitals, you have rich data set of multiple non-affiliated hospitals, right? Because without centralizing the data in one place. So, basically, ultimately, it overcomes the data privacy, security, data access rights, and then access to heterogeneous data. Right now, the challenges, right? The communication across federated network, managing heterogeneous systems in the same network, and then basically the statistical heterogeneity of data in federated networks and privacy concerns of privacy preserving methods. Okay, so now the application and use cases, we have edge computing, healthcare, Internet of Things, Internet of Vehicles, anomaly detection, smart city, financial fraud identification, visual object detection, and fog computing, right? So, so the federated learning can be privacy sensitive data, right? Or, if you want to keep any private data without going into or without sharing to the centralized machine learning or for training, it is being done at the edge, right? So, like healthcare, finance, and some other institutions, right, where the data sharing is prohibited, they will get a approach for training ML model, right? And that is what it is. So, okay. So now, finally, when we are combining this artificial intelligence blockchain, right, we are talking about, two emerging technologies and different things, right? So here, we have blockchain will do the decentralized infrastructure, immutability of data, transparency network, all other things. And AI basically does the predictive analytics and decision making, right? So, and we have, Internet of IoT, we have network of connected devices, it can be fog or whatever, right? And then, with sensors. Okay, so some of the use cases, for smart city infrastructure, you can have a combination of AI and blockchain technologies to improve the logistics tracking, real-time failure detection, and then data and device authentication, right? So this is basically a combination of AI and blockchain. And then fake document detection. You can scan all the articles, reference website, and see which are fake, right? To ensure that content is truthful and credible. Similarly, authenticity of artwork, where AI and blockchain to certify and verify the work of art in real time. Cybersecurity and maintaining blocks. Blockchain act as a cybersecurity tool for digital edges and use AI to control the process of building and maintaining the blockchains. Reward-based data sharing marketplace. Encourage users to share their data, enables data purchases in the advertising, education, entertainment, and pharmaceutical industries to access large pool, right? So here, these are all pretty new use cases, and there are companies, they are working on similar kind of use cases, right? And combining an AI and blockchain to create a platform for intelligent AR and VR avatars, right? So here, using this combination, they can create a more personal and social experience in the virtual world. Is what it is. Similarly, AI-powered data exchange platform, real-time mapping tool, insight, dashboard, and blockchain for autonomous vehicle can quickly absorb, interpret, and safely store the data. All right. So, using AI to give healthcare professional blockchain-based access to medical intelligence and insights. Union of AI and IoT include predictive analytics for manufacturers, remote patient monitoring for healthcare workers, integration of edge computing, blockchain, and AI for distributed security mechanism and payment solutions. All these are, each of this, can be gone to details. And then, there are multiple people, multiple companies which are developing algorithms in order to solve the business process by combining artificial intelligence and blockchain, right? So with this, I come to conclusion of this talk. And then basically we're thinking of doing one more demo. Basically, because of the lack of time, I'm not going over it for now. Basically, it is the SHA-256 hash and how the multiple blockchains are happening in transaction, and the nodes and the previous block and other things. Uh, you know. Okay, and then there is something called solidity, which is used for smart contracts, and then solidity code, and then we can just compile, deploy, and other things into the blockchain network, right? So different steps are involved, and so we have Alchemy, MetaMask, Hardhat, and then Etherscan is to verify all the smart contract and blockchain related items, right? Virtual wallet, smart MetaMask is the virtual wallet. So, all the steps are here. And then in AI, we have deep learning, LSTM, and then we have transformers. So, basically the LSTM is like, again, a long short-term memory, the artificial neural network in the field of AI and then deep learning. And then there is another variety, it's called transformer neural network. It is like a sequence task, basically doing handling long range dependencies it is, right? And so both LSTM and transformers are great, for modeling sequence information. So they can also be applied to time series forecasting. So these are some of the AI, algorithms which I thought of showing, demo. Okay, so now, the questions and answers. If any of you have any questions, you can reach out to me by this email or by my LinkedIn, which is given here. And I appreciate your time. And then if you have any questions, please, you can ask now. Thank you. Thank you so much.